Good. So after architecture view modeling, we'll look at architectural patterns. A pattern is a well-known concept in software engineering. I will first explain the motivation behind patterns. Okay, for those of you who have got in the course object-oriented design, you got some patterns knowledge, right? But I will explain it from the beginning, from the key motivation. What is a pattern and what does it mean to have architectural patterns? And later on we will look at concrete architectural patterns, concrete examples of architectural patterns. Actually, it's the issue is the engineering we can see as problem solving. Problem solving starts with requirements. You define the problems. We look at solution domain. We derive solution description. We identify alternatives. We evaluate these alternatives. And we derive the artifacts. In general, the mature engineering disciplines adopt this problem-solving model. So, if you look at at problem-solving, what do we see? Many problems actually recur. Usually in practice we don't solve novel problems regularly, but people usually, existing problems recur. These problems have the same solution structure. Each solution is dependent on the context, so we have the solution structure, but the context changes, so somehow we adapt it. And a more experienced person can solve new problems faster and better. Okay. If you look at Novice for children, children know a few problems, knows a few solutions, invents new solutions for each problem. Okay, you have a problem, just try to invent from scratch, has seen operated in a few contexts, cannot easily match problems to solutions in different contexts. So you have problem, but what's the related solution? Solution is based on trial and error. So like children, they solve also problem, but it's basically like play. Okay. Expert knows many problems, knows solution to these problems, recalls generic solution when encountering new problems. Like a consultant, architecture consultant, saying, hey, I have this application, but I have seen this problem before. Okay? But the context is different, so it knows various different contexts, but knows how to apply this knowledge. In short, actually, we say, expert knows many patterns. Okay, we have a problem, solution, but the context is different. And exactly this combination is just a pattern. If you are an expert, actually you have more patterns in your brains, in your head. Okay? If you are just starting, a novice, you don't have these patterns. So experience, the broad sense, experience here can be defined as the set of patterns, the number of patterns that you have, that you know. The whole pattern ID has been derived from the work from the architect Christopher Alexander, especially in this book, The Timeless Way of Building. He says, okay, when a person is faced with an act of design, what he does is entirely governed by the pattern language which he has in his mind at that moment. You have to design. Actually, when you design, you do it using the patterns. The pattern language in each mind are evolving all the time as each person's experience grows. So the more experience you have, the more pattern you will have. His act of design, whether humble or gigantically complex, is governed entirely by the patterns and his ability to combine these patterns to form a new design. Okay. Act of design is governed by patterns in your mind. The more patterns you know, the better you can design. So Christopher Alexander, what he defines as a pattern is a three-part rule which expresses a relation between a certain context, a problem, and a solution. You have a context, in a context you have a problem, and you have a common solution. A generic solution to a recurring problem. Okay? So what did Alexander focus on? He's actually an architect, he focused on buildings. His statement is all buildings are the result of actually applying sets of rules, applying the patterns, pattern language. When this expertise fails to be passed on, bad buildings and broken communities will result. Okay? That means you will just build ugly buildings, okay? Because you have not passed over the expert knowledge. Current architectural methods result in products that fail to meet the real demands and the requirements of its users, society and its individuals, and are unsuccessful in improving the human condition. So he criticized the existing state of civil engineering, of buildings. Okay, and the reason for this is actually this, he says. Okay. The good experience is not passed on. Related to this is his experiment that he did on Harvard, at Harvard in the 1960s. He asked subjects to rank order a set of strips, these from most coherent and simple to least coherent and simple. Okay. So look at these strips. We could do the same experiment here. Look at these strips and rank order these strips from least coherent to most coherent. Okay. Hypothesis here: if there was a good agreement among the subjects about which were simpler and more coherent, then there would probably be some truth to the conjecture that there's an objective quality of wholeness or coherence or simplicity. That is, if you would do this experiment here and you have all the similar rankings, then we could say, hey, probably there's some objectivity there, objective quality. Okay. What he did is he analyzed the symmetries of these strips. Okay. For each strip, he analyzed the number of symmetries and he ranked ordered these with respect to the number of symmetries. The conclusion was his rank ordering with respect to symmetries was almost similar to the results of the experiments. Okay. That's what he said: the perceived coherence of the different patterns depends almost entirely on the number of symmetrical segments which they contain. Most coherent patterns are the ones which contain the largest number of local symmetries or subsymmetries. 93. Okay. So he does just a subjective experiment. These are the strips. Go and rank order. And he rank orders the same strips with respect to symmetries, like, well, this one has 9 symmetries, very a lot, and you have fewer symmetries, and it appears that they are similar. Okay? So symmetries, patterns, he says. Another experiment, what he did, this is nice experiment. It's written in this book, a foreshadowing of 21st century art, the color and geometry of very early Turkish carpets. Here he looks at the carpets, not at buildings, because it's also artifact. Carpet has also patterns, has structure. In this book also he makes similar statements. And he explains some experiments. If you had to choose one of these carpets, so that's the next slide, as a picture of yourself, then which one of the two carpets would you choose? Okay. That's this. We will focus on that in a minute. In case you find it hard to answer the question, let me clarify by asking you to choose the one which seems better able to represent your whole being, the essence of yourself, the good and the bad, all that is human in you. So just like in the strips, he says, in the strips he said, rank order these with respect to the coherence, and here he says, look at these two carpets and say, okay, which one you would choose. He used the terms a picture of yourself or coherence. Okay, I did this experiment several times. You can look 1 minute. Left or right? Or none of it? Left or right? Who says left? Right? Left is this one, right is that one. Who says left? Okay. It's just an experiment. He did this experiment with many people. So what did he observe here? Of course, this is not the real experiment, but in the book you see it's more clear and you have more time. I believe, Alexander says, that almost everyone, after careful thought, will choose the left-hand example. Of course, this is missing some parts, but actually the idea is similar. Even though the two are of roughly equal importance and comparable age, I believe most people will conclude the left-hand one is more profound. That one feels more calm when looking at it, that one could look at it day after day for more years, that it fills one more successfully with a calm and peaceful feeling. All this is what I mean by saying that objectively the left-hand carpet is the greater and the more whole of the two. So he is quite... no, he's a famous architect. What he did is just similar, like the strips, but this is now carpet. On the one hand, just experiment with real people. On the other hand, more objective evaluation. What did he do? He looked at the number of what he called centers or patterns. And it appears that this carpet has more patterns than this one. Okay, based on that, he says, hey, the more patterns, the more you have. He has also more sophisticated metrics, about 15. The more coherent, the more nice a carpet will be. Okay, that's the idea of the patterns that we use actually. Why do we use patterns? To improve quality. In this case, aesthetics. So that's more visually appealing. This is nice, okay? Or building. It's a nice building. Why? Then the hypothesis here is that it includes more nice patterns. If that's the case, okay, we could say, so what? Okay, if that's the case, then it is important to make these patterns reusable. Okay, we have patterns for buildings, patterns for Turkish carpets. Okay, by the way, he also studied these Turkish carpets. Okay, he traveled to Turkey several times, to Konya, and then what his statement was also similar to buildings. The current carpets are less aesthetic, less coherent than for example, the carpets in the Seljuk period. Okay? And he defines objective metrics to prove that, which is quite interesting, right? So he provides actually objectivity to aesthetics. What is beautiful using objective metrics in a scientific way. That is interesting. And that's not only interesting, it's also the basis of the pattern ID that we know. The software design patterns is just from that ID. Okay? Because software has also structure. The idea here is, if that's important knowledge, make it reusable. Capture this valuable pattern knowledge, make it reusable in a catalog or pattern base, so that other engineers, designers, builders, carpet designers, software designers can reuse these patterns to build systems faster and also with higher quality. Nicer carpet, nicer building, more adaptable software design. Okay? That's the idea. Patterns are actually discovered. Okay? How discovered? So you have some problem, you invent a solution structure, another problem, solution structure, another problem, solution structure. In the end you say, hey, for these recurring problems, you have the similar structure, generic structure. Then you say, this is a pattern. You have a pattern in some context, recurring problem, generic structure. Before the patterns ID in software design, in early 90s, also software engineers applied patterns, but they didn't name it. It was just expert knowledge. Once the ideas of Alexander were introduced in software engineering, we started to name these patterns, to record this. Okay? And after that, we can say we have adapter pattern. Everybody knows, hey, that's a software design pattern. Patterns are not invented. You cannot say, hey, today it's my good day, it's a rainy day, what I will do is to invent pattern. Doesn't go like that. Okay? You see, you work in several software design projects, you see similar kind of problems, and then you see that you conclude that they have similar structure, and then you can discover these patterns. But it's not invented. So how do we describe patterns? Usually this is the format that you will see very often. You have a name of the pattern, the problem that it addresses, the goal, the context, the preconditions and patterns applicability, the forces, what happens if you apply this pattern, in which context does it apply, the solution, the example, the consequences, what's the consequence of applying the pattern, motivation and related patterns, what's the relation to other patterns. If we look back at Christopher Alexander about buildings, he talks about pattern language because in this book he describes 253 individual but related patterns. It's a pattern language because he starts to define actually the whole world from the very abstract level to the very low level. These patterns help to build structures that are good for people and have positive influence on them by improving their comfort and their quality of life. An example of this pattern is this. Light on two sides of every room. This architecture pattern for defining buildings. It's a problem. As human beings, when they have a choice, people will always gravitate to those rooms which have light on two sides and leave the rooms which are lit only from one side unused and empty. Okay, so that's this ID. Usually we prefer to go to rooms which are lit on two sides. If that's the case, if you define a building, if you plan the rooms, the structure of the rooms, locate each room so that it has outdoor space outside it on at least 2 sides, and then place windows in these outdoor walls so that natural falls light into every room from more than one direction. So this is the case. If you have this case, so here the idea is locate each room so that in each room you see 2 lights.
I want to ask some questions. For example, following patterns we always did the same way, but in that specific question, can't we find a better solution?
For this?
No, anything with patterns. Because it's a general solution as far as I understand.
This is the pattern actually describes the expert knowledge. In that sense, it's for that problem, the best possible way to structure, the best possible solution. Okay? Is there a better solution? Then you would have a better pattern. That's the idea. Okay? So if your problem is exactly the problem of the pattern, if that's the match, then the pattern, the described pattern, the structure is the best solution. But if it doesn't match exactly, so somehow it doesn't, it's not the exact goal of the pattern, you could have better solutions. But for the problem that is addressed by the patterns, it is the best possible solution. Okay, we said patterns are discovered. Patterns define the expert knowledge. Okay, in that sense, it's the best possible solution. Of course, in a system, you don't have only one pattern. You have multiple patterns and combination of these patterns. So you have to maybe do some trade-off analysis. If you apply some pattern, for example, it will be more adaptable, which will be the intent, which is the intent of the pattern. But you will lose, for example, performance. Okay? The pattern says if you want adaptable design, apply this. But if you say I want performance, then the problems do not match. Okay? It's clear? Well, this is from buildings, and I think the software architecture patterns are the similar idea. Okay, you have problem, you have solution structure. In Turkey, you know Mimar Sinan. It's interesting. I looked at this also. He has very nice buildings. If you apply the theory of Alexander to Mimar Sinan, he has the very nice, beautiful buildings. Then it would actually mean the same. So if he then, does it mean then that Mimar Sinan has also applied patterns? Okay. I was curious about that, and then it appears that indeed there's some Mimar Sinan project where they analyzed these buildings, and they analyzed also the structure of the mosques. Here, this is the mosque with domes supported by 4 piers. It's the basic pattern. They provide some guidelines, common guidelines. Mosques in this category have domes resting on a square base formed by 4 piers and horizontal connecting elements in between, etc. And this is the category of these mosques with four piers. Plus the variations, like you have also the application of the patterns. In a similar sense, this is with 6 piers, okay, all the patterns, and with 8 piers. Selimiye Mosque, for example, is one of the famous mosques. It appears that it applies this kind of pattern. Okay, I didn't do a detailed study on that, but if the theory of Alexander can just be applied to actually to any artifact which has structure. Patterns are not designs. Okay? Patterns are templates, a blueprint. You have a template, and you should instantiate that template. So you have to make design decisions. You have to evaluate trade-offs, combine with other patterns. And there exactly is, of course, in the applying the patterns, you have already some alternatives. Okay, there you could have multiple solutions. Okay, if you look at patterns in engineering, we see that all mature engineering disciplines have actually pattern catalogs, including patterns that have been discovered by experts and which show proven quality solutions to recurring problems. For example, in electrical engineering, if you encounter some problem, the engineer, what he does or he or she does, typically look at existing pattern catalog. Like here, 3,000 solved problems in electric circuits. 3,000. Okay? So he or she doesn't solve it from scratch. So it's a problem, looks at this book, match, then apply. And for sure it's the best possible solution because this is a consensus of experts in that domain. Then you get the solution. Mechanical engineering, just similar. Mature engineering for centuries. Problem, look at the this book, for example. It's about 3,000 pages. Define the solution in the mechanical engineering domain. Chemical engineering, problem, don't solve from scratch. 2,000 or 3,000 pages here, including the problems, the common structure. Problem, match, look at the structure, apply it. Okay? Generic problems, here this includes generic problems with, recurring problems, common problems with generic solutions. How about software engineering? Software engineering, the patents ideas start about the early 90s, so about 15 years, 15, 16, 17 years. This is still recent actually if you look at the other engineering disciplines. Here there are several books on patents, especially I put here the software architectural patents books. If you have a problem, so the idea is then that we should also can look at these patterns and define the solution. We can categorize these patterns in software design in different ways, from abstraction level, and then we talk about architectural patterns. In more detailed design, we have design patterns, and even at the programming level, we could have patterns, which is called programming patterns or idioms. Further, we could have also organizational analysis, UI design, etc. So patterns ID has been invented and it's now actually introduced in all different phases and domains of software engineering. Software architecture patterns are patterns at the highest abstraction level, express a fundamental structural organization scheme for software. So its architecture patterns provide set of predefined subsystems, so global structures, specifies their responsibilities and includes rules and guidelines. Example is the layers pattern. The problem, a large system which is characterized with a mix of low and high level issues, where high level operations rely on low level issues. If that's the case, then say this pattern says structure your system as a layers pattern, using a layers pattern, in which you identify several layers, and these layers are stacked on each other, and layers on the higher level layers can only address the nearest lowest layer. Okay, this is just pattern. Software design patterns is actually from this book. It's very quite common, from Gamma et al. It's more detailed design patterns. There they have 23 object-oriented design patterns. You have here design pattern community. There's even every year a conference on patterns. These are the 23 design patterns in this book. This is an example, the adapter pattern, the problem. Convert the interface of a class into another interface that the clients expect. So you have this client works with some other classes, so target, and the client accesses uses the interface request. There's another component or class which has a different operation. We would like to reuse this, but the client should not be aware of that. Okay, excuse me. So who knows this pattern? Have you seen this pattern before? No. Okay. So what does adapter pattern do? It lets class work together that couldn't otherwise because of incompatible interface, request, specific request. So how do you solve this problem? This is not a new problem. Okay, it's a recurring problem. So what the solution is you subclass from this, which is the adapter class. This is the abstract operation request. You put the request operation here. And what's the implementation of request here? Sorry? So it calls this as the adaptee, and it says return adaptee.specific request. Okay? Solved. The client can just access this, just say request. Okay? And this is just reused in these components. It's a recurring problem. Generic solution structure. It solves. We have also programming patterns, or idioms. Is a low-level pattern specific to a programming language, like for C++ or Java. Okay. Example of a programming pattern: fast synchronized initialization. Problem: it is often the case that we don't want to construct an object until it is first needed. Okay? Because maybe the object is large and you would like to actually, for performance reasons, you don't want to create it until you really need it. So what you do is here, the object that you want to create is a static object. In the operation in which you use the object, you check if the object is nil, then you create. Okay? If the object is not nil, then it's already created, then you can use. So which means that you don't create it actually, so you just declare, but you just wait until you use the object. It's a pattern. Okay? This is the problem. Don't construct the object until you create it. This is the solution. This is just one example of a programming pattern. There are many others in these books. So what we should do is define these, put this in these pattern catalogs. Pattern catalogs is a collection of patterns that can be reused. It's called a catalog if you don't have explicit guidance. Yeah, it's just up to you. You just select, you get it. We call it a pattern system if you put explicit guidance. You have a collection of patterns together with guidelines for their implementation, combination, and practical use in software development. It describes how patterns are connected, how they complement each other, describes the patterns uniformly, exposes various relationships between these patterns, organizes patterns for quick retrieval, and supports construction. So it doesn't just list the patterns, but also puts some guidance. And then we say it's a pattern system. Actually, the most mature level is the pattern language. It defines a collection of patterns from the highest level to the lowest level, so there's fully integrated. We say it must be computational complete. For example, Alexander's pattern language on urban design and architecture. These are the patterns, very high abstract level, starts with independent regions, distribution of towns, okay, activity nodes, etc., until pools of light, so it looks at even rooms. This is high level regions. How do you set up the regions? How do you set up the neighborhoods, the houses, the rooms? Okay, because we say it's a complete language, computational complete. Okay, summary about this introduction, motivation for patterns. Patterns are reusable abstractions providing solutions for recurring problems. Patterns ID has not been defined in the software design community, but it's from civil engineering actually, okay, buildings. But we see patterns are applied in mature engineering, and what we do here is patterns can also be applied in software engineering at various abstraction levels. Architectural design program, we can distinguish between pattern catalog, pattern system, and pattern language. We will look at the concrete examples of architectural design patterns. Questions about this, so the whole idea should now be clear. It's not just the another ID pattern, but it's actually one of the key IDs. Okay, let's break.